All right, welcome everyone. This is the monthly users community meeting for Kyverno for April 21st. So we have quite a few topics on the agenda. So I'll let Shooting introduce the main topics and we'll dive right into it.
All right. So hello everyone. Today we prepared multiple demos for the features and critical fixes in 135. And then we'll be talking about the current work in Kyverno, what we decided to release in 136. There may involve some of the discussions for particular features that that are two main sections for today. So let's first start with the demos. So in 135 we have, oops, I lost your screen.
Yeah, I just stopped sharing so Pooja can share.
Okay, let me just quickly describe that feature. In 135, we have added this built-in variable images that you can use that in the mutate or generate or validate policy to extract the image properties. Let me hand off to Pooja. She will give us a demo for that.
Yeah, hi all. So let me give you a very quick demo for this. So here we have a very simple policy. So this is a validate policy. So this is basically just to show that what feature we have introduced. So this policy will be applied on kind pods, so all the pods. And here what we are doing is we are comparing the uh, image registry and its name with Docker Nginx. So whichever pod we are going to create, that pod should not have the should not have this image. So this is like basically the image and the registry. So this combination shouldn't be there. So here we have an example. This, as it is a deny policy, so when it matches, oh yeah. So here, as we can see, this is a very simple pod. And here the image you can see, I have just written it as just to show Docker test.io and Nginx, and the name is Nginx1. So when I'm going to try to create this pod with the policy, this should fail. So this is the policy, and this is the resource I'm going to apply. Use 0. So serial get. Okay, so it is running. My Kyverno cluster is running, and I'm going to apply the policy. So it is successfully applied. Now I'll try to validate first this part. This will be restricted. And the same if I try to go with this, where this exactly matches. So this is getting created. So this is basically, if you check here, which is failed. So here I have given the image information, and that is dockertest.io, and the image name is Nginx. So, and if you check the message here for the image variable, So I'm getting all the registry and taking the first element. So that is like you can also test for the multiple containers and use the image variable. So here, if you will see, this is Docker test, and here the value is replace. And for the name, so which is this Nginx, and here we can see this. So with this, we also have like if anyone is not mentioning any registry, by default, Kyverno will take it as docker.io. And in case any validation is there with the tag, so and tag is not mentioned, it will be taken as latest. So let me just show you the tag ones. I'm just going to add it in the message. So here, if you will see, I have not added any tag. When I'll try to apply it again. Oh, I need to apply the policy also. So apply. Yeah, so here you can see by default, we add a tag as latest, and in case the registry is also missing, we will add it as docker.io. So the documentation is also available on the Kyverno website. You can also go through the uh, different aspects of this and the what all kind of uh, variables you can use.
Yeah, so Pooja, I just pasted that link. If you want to quickly show the structure of that images variable, that might be good context.
Yeah, sure.
I haven't looked at the code, but what is the internal logic that uses to find the registry value versus the image value? Are you looking for like the last slash and then doing a read behind? The reason I'm asking is how would it contend with a registry which has multiple forward slashes in it?
Yeah, I can take that. Internally, we're using the external library to parse the images, but the idea is to use the slash to split the registry, the name, and the column to split the tag.
So if I had an image that was registry.corp.com/foo/bar/baz.
Yeah, the first part will be split as an image registry, and then the rest part will be the image name.
Okay.
Yes, I think like Shooting mentioned, we're just using a standard library, which is also used in Kubernetes and a few other projects for this image parsing.
Yeah.
Okay, so here we can find the document related to this. So you can check it under the variables. We have predefined variables and we have added the images for this. You can check here. So this is how it works and how Kyverno saves the data. It saves it as a map, the container and init container data. And using this, you can use different variables in policy. So here you will be able to find different variables, like the ideas or what you can use in it. And also with a node, this is like if the registry is empty, it is a docker.io and empty tag list is latest. So this is sorry. So these are like different kind of variables you can use here.
Okay, just add to that, not only the registry name and tag are available, we also have the digest. So you can also extract that property from the images.
Okay, yeah, and what will be interesting is combining this now with the 136 feature where we can have, different JMES path functions to do substitutions, etc. So it should be fairly easy to do things like substitute registry names, or even tag names, things like that, based on some conditions.
Right. Okay. I guess that's it, right, Kajira?
Yeah, that's it from my side from the demo. And then I'll hand it over to you, Shooting.
Okay, thanks. All right. Next we'll have if you follow the events happened in the Kyverno Slack, we have Frank, who is working on the policy reporter, which is to add support policy, Kyverno policy reports, and you can have amazing dashboard there to get the view of the policy report. So let me hand off to Frank. Hey, Frank.
Hey, everyone. Can you hear me?
Yeah, I can hear you.
Oh, great.
Do you want to?
Yeah. Sorry?
I'm just saying, do you want to talk about your policy reporter a little bit more?
Sure. I have created a small demo. Maybe it's better to see it in action.
Yeah, sure.
I would share my view at desktop. Yeah, I created a small Minikube cluster.
Excuse me, can you zoom in a little bit? It's kind of small.
Sorry?
Can you zoom in a little bit?
Yeah, sure.
Thanks.
Yeah, it's prepared with a monitoring stack with the Prometheus operator and Loki stack installation with Loki and Promptial installed, and basic Kyverno installation with current release. And yeah, that's it for now. I use simple Helm install commands to create the monitoring stack, and I have prepared a configuration for the policy reporter UI. So the policy reporter has different functionality. I think the main one is the monitoring with metrics, but also the UI, which works independent from Prometheus and other external components, and can also push new violations to different targets, like Loki in this example. And in this small cluster, I enabled the UI with a simple enable. I configured Loki with the internal UI. You can configure which violations you want to send to Loki. Medium is severity medium, for example. Warning is severity medium, for example. You can also send it, set it to critical, which is severity high configurations, and you can skip existing ones. So when you have an existing cluster with hundreds of violations, you don't want to send this 400 violations directly to Loki, only the new ones. That's the basic idea. And the second part is the configuration together with the Prometheus operator. So yeah, I enable it. I have to specify the namespace from the monitoring stack. It's an internal thing from the operator, and to grab the service monitor created from policy reporter, I set a label which is dependent on your Prometheus operator stack. With this configuration, I execute my install command, and yeah, it creates two parts. The first one is the policy reporter itself, so the different APIs, and the second one is the UI, so it's an independent application, which is additional in this case. With this installation in place, you can use the different kinds of APIs. You can show the basic metrics. So these are informations about all violations exist, violations and also past results. So you can build dashboards for past results, failed results, warning or error. You can access the UI, which is installed as additional feature. So yeah, this works in the basic setup without all the Grafana and Prometheus stuff installed. It uses REST APIs created from the policy reporter. So these REST APIs are independent from the UI. In general, you can also use it for your own implementations. It has two endpoints, the policy report and the cluster policy report. So it converts this metrics into RESTful JSONs, which are better to process in additional tools like the UI. And at last, we can have a look to Grafana. Which already has a pre-installed dashboard. This dashboard also comes from the policy reporter installation. It uses the operator functionality to create config maps in the namespace of the monitoring stack. That's why you have to specify the namespace. And Grafana grabs these config maps and creates dashboards. This dashboard has basic information. You have a general overview. It's identical to the UI, the policy reporter UI, with this graph in addition. And you have more detailed information about policy report details. So it's split in past results and failed results. You have many different filters. You can filter for the kind, you can filter for namespaces or for a single policy. With the new feature and support for category and severity, you can also filter on this thing. And we have the same for cluster policies, but yeah, per default there's no enable. So I can apply one. It's a very simple policy which checks for an end variable on the namespace, and it should show us this graphs in a few seconds. We can also have a look in the dashboard where we already have the new information. The UI refreshed its stats after a few seconds, so you don't have to refresh the UI and get the new dashboard, new information nearly instant. And you have also here the ability to filter for different information. I have also this log section where we can see that I added a new policy which has 3 violations, and these violations already showed up in this log overview. We also defined Loki as target, so it should be possible to also see the same violations in Loki. each result gets a custom label with source policy reporter, so it's more easy to grab all violations. And yeah, here we also see the violations in our low-key stack, which is more for production purposes because UI has this limit. Yeah, I think that's a basic overview. Any question on that?
Very cool work. Nice job.
Thanks a lot. Cool project. Yeah, besides Loki, it supports many different targets. You can show, or I have more detailed documentation in the wiki page of the policy reporter. There you have screenshots, all support the targets for now. You can send it to Slack and Discord. Also, Elasticsearch is reported. You have detailed information about what to configure and how. Yeah, if you have any question, you can ask me or have a look in the documentation. Hopefully, it is also there. So.
Yeah, this looks great. Thank you. And just a quick shout out, Frank is also helping upgrade the policy report to the latest CRD schema. So with that, we'll have more also flexibility in terms of customizing things like the severity, whether a result is scored or not, things like that, based on annotations or information in the policy itself. And that's ongoing work. So maybe in 136 or a subsequent release.
Yeah, and policy reporter has already support for the new version, and it will still support the old version. So it works with both.
Great stuff.
Yeah, it's an amazing tool, and me myself also tried out policy reporter UI that brings up kind of a reporter in the standalone mode and found it really helpful. Thank you. Thank you, Frank.
Yeah, thank you all for your help and time. So, yeah.
Cool. Let me quickly pull up my screen. Okay. Next I want to talk about this auto recovery of the policy report. So in 135, we introduced this feature that in case your policy report is deleted accidentally, Kyverno will try to recreate that policy report. And then by default, we have the background scan scheduled for every hour. So the report will get reconciled for each hour, but that is configured using a flag background scan in one of the Kyverno args. So it's configurable, but yeah, let me pull up my terminal. I just want to quickly show you if any of the report is deleted by accident. We will have the Kyverno will try to create that again. So here is the single policy report I got in my cluster. And then if I say kubectl delete policy report is the name. And then if you get policy report again, you'll see that is created immediately right after it's deleted. And then for each for each background scan interval, it'll also try to wipe out all the result entry and recreate that again, just in case any of the delete or there's any invalid policy result entry left in the policy report. So we won't delete the existing one, we just wipe out the result entry and then reconcile that. Okay, this is just a quick, like kind of a reminder of the behavior change. And let me continue with the demos. Next, we have this mutating URL path And also I think there is another mutate for autogen rules. Let me hand off to Venkatesh. He'll have a demo for that.
Hi everyone, my name is Venkatesh, and today I'm going to demo the mutating URL path for the autogen. So the URL path query to the Kubernetes API server must be specific path to the resource. For example, while creating pod, the JMS path expression needed to, if the JMS path expression needed to grab the value of first volume secret field that required the request.object.spec volume 0, the first volume, then secret and the secret name. But for the deployment, we require like the request object specs template, and then spec volume, the first volume, then secret and the secret name. And for the cron job, we have the another like the path is request object spec, the job template, then specs object, then template, then again specs volume 0 and the secret name. So in this release, we have the facility that allows the smart mutation of any JMS path expression, which goes into the specs object to change the expression based on the controller. So the Kyverno will see the policy, look into the kind, and it will check is that kind is pod or not, and then it will search for the JMS path expression, which goes into the request object specs JSON and mutate them for all various pod controller. So here I have the policy. So as you can see, we have the URL path for the secret, the JMS path. So now I am going to apply this policy, and then we can see the autogen rule will convert this path for the deployment stateful set and for the cron job. Yeah. So the policy grid. So as we can see, for the cron job, we have the job template or specs. So this path get mutated for the cron job, and for the remaining the kind select deployment domain sets, and for that the path get mutated. So like that, the Kyverno will mutate the path for the JMS expressions. So any questions on that?
Will it scour the entire policy and look for those James path expressions that go into spec, or is it only in certain fields like API call.url path?
No, it will go to the.
Oh, it's all message too. Okay.
Yeah.
So it does it everywhere in the policy?
Yeah, everywhere in the policy.
Will that only work if the kind is a single kind and that's pod? So if the kind is pod in deployment, for example, will it trigger that?
Yeah, if the kind is pod, it will trigger that. If
right, but my question is if it's multiple kinds, if it's not just pod, if it's two kinds in the same rule.
Yeah, so I think in that case, autogen is not triggered in that case, right? So then it will
okay, so it's only pod.
Right.
Okay.
So I don't recall the exact conditions when autogen triggers, but I think it makes sure that the policy is only for a pod. And I think there were, if I recall, there was some other additional checks. Shooting or anyone else know offhand, like what exactly is the condition for autogen?
Yeah, I think there's an issue created for that, right? If we have mixed kinds defined in the match block will probably still generate the autogen rules, but that's one of the enhancement or the fixes Venkatesh is currently working on.
Right. So it should not trigger, because in that case, the intent is that the user is sort of controlling the kinds. They have specified multiple kinds. Yeah, so we should skip it.
Right.
Okay.
Yeah, that's what I was getting at. And I see that it allowed you to create the James path expression for your API call .James path field without the double curly braces. So I don't know if that's technically valid or not.
I think this is when the output of kubectl describe.
Well, his input policy was that way too. So if you go back to your editor, so your editor right there, API call .James path isn't enclosed in double curly braces. So is that technically valid? Because there's no var substitution in that case.
Right. Yeah. So I think for that field, it doesn't require it's not a variable, right? It's saying apply that.
Okay, so that
James
works
path,
regardless
right.
then.
Right. In fact, I think it would fail if you put double curly braces, but I'd have to
Okay,
check.
I couldn't recall. Yeah, this is a great thing. This is going to solve a lot of problems with some policies. So this is just an extension of the existing pod controller, correct? This isn't a new controller that's implemented.
This is the extension of the pod control.
Okay.
Okay. So the second demo which I have, so I'm going to install the hem, and with that we will get default the pod security policies. So I'm creating my cluster. So I will freshly install the Kyverno using helm. Yeah. So first I will follow the steps which we have. So I already have the helm repo, not an issue. So now I'm going to install freshly going to install Kyverno. So right now I don't have Kyverno.
We do have a handy copy button right there in the code blocks, just saying.
Yeah. So Kyverno get installed. Okay. So when we install the Kyverno using him, we will get the all the pod security policies. By default install, and the previously before release we have the issue with the pod controller for the hen. So if we describe this cluster policies, so as we can see, the autogen rule is working for all the pod security policies using helm. So the cron job and
the reason we want to bring this up is that previously, if you install Kyverno using ham, there like Kyverno won't mutate this pre-install policy, like those policies installed before Kyverno came up. That brings us an issue that if you have the cron job or any of the pod controllers installed in your cluster, there will be a bunch of policy result reported on the pod itself, and that kind of take up all the resources, and sometimes we fail to update the report because the result entry just got piled up. So this is to amend that, fix that issue, and we will scan all the existing policies and mutate the defaults if anything is missing. Okay, cool. Thanks, Venkatesh. All right. Next, I saw Yash, you have added the Prometheus metrics to one of the demo topic. Do you have the demo ready, or you just want to? Maybe you can just give us some updates, the status updates about that.
Sure, I'll actually I'll show the demo, a quick demo along the updates as well. So
Okay.
let me start sharing the screen first. All right. I guess the screen should be visible now.
Yep.
Yeah. So if you remember from the last meeting, the community meetup, I mentioned about that we are working on a Prometheus integration of Kyverno, where Kyverno is going to basically end up exposing a nice bunch of metrics, which the Kyverno user can actually utilize to get really insightful, really good insights around how Kyverno across their cluster is performing, or which policies are being violated, what rules are there, basically any metric associated data. So we actually cumulatively we decided to expose 5 metrics, and right now, up until now, 3 of them are done, the 3 major ones. So just to give a quick showcase of which of them are ready. So basically right now we are 3 of them are ready. Kyverno policy changes, Kyverno policy rule count, and Kyverno policy rule results. So let's talk about let's firstly talk about Kyverno policy rule count. So basically with this metric, the user can get insights around how many rules their cluster, how many Kyverno rules their cluster possesses, how many Kyverno policies their cluster possesses, or they can even go even further granular at the level of the rule. Like for example, like specifically how many validate rules are there across their cluster, or how many generate rules are there across their cluster. And if you look at the metric right now, I'll zoom in a bit. So if you look at these metrics, so if you look at the metric value here, right, you are seeing 110. So basically 1 conveys the fact that this metric, this rule currently is existing in the cluster. But if it's a 0, then this means that the policy was, this rule was created sometime in the past, but then it got deleted. So that's the thing. So if I just want to see how many rules are currently active in the cluster, I can just simply execute this metric, right? And let's say I want to see, okay, I don't want to know about any of the rules. I'd rather want to know about the policies instead. How many policies are inside the cluster currently? So I can just do a count simple by, and I can group by the policy name. Simple, and it's going to actually categorize all the rules present at the level of policies, right? And let me actually, you can actually visualize this as well. So I can make a count here. Just a second. See, so this is basically showing the trend of the rules which are arrived throughout the Kyverno's life cycle. So initially there were like 2, and suddenly 2 of them were deleted. Then again they were brought up alive. And if we go just at the level of rules instead, so yeah, similarly, basically, yeah, like alive rules are these, like only currently these rules are alive right now. And if I go further, so you can see there's a count of 3 total rules. So I remove the filter of aliveness or the deletions of the rules. So this metric currently, this metric in front of your screens is actually showing that across Kyverno's life cycle, in total, how many rules were either applied or deleted. So that's what it's showing. Now, so just to end up discussion regarding this metric, I'll end up with showing the exact labels or categories on which a user can filter these. So user can filter on the basis of background rule to see that how many rules or other actually policies are capable of running in a background scan mode, right? Because some can run in background scan and some cannot run. Also, there is a policy namespace field. So for example, in Kyverno, we have the construct of namespace policy as well, right? With the kind policy. So this policy namespace label actually complies with a construct. So If I just want to see how many rules are sitting inside, let's say, default namespace, or how many policies are sitting inside default namespace, I can just filter on the basis of that. And speaking of cluster policy, so for cluster policy, the namespace construct is like futile. So for that, the policy namespace field is going to be populated with a hyphen. And similarly, policy type is there, cluster or namespace. Policy validation mode is there, either enforce or audit, depending on the policy. And finally, the rule name. Sorry, finally the rule name, which will depict that exactly which rule is this, and rule type. It's either going to be validate, mutate, or generate. So basically, you can see that this metric ends up providing the end user the capability to, map out exactly that what across the cluster, what has been the state of, the quantity of the rules or the policies across the cluster. And it also provides the qualitative aspects, like with the capability of filtering on the basis of background mode or other granular details of the policy or rules. So this is one of the metric. The second metric is the policy changes metric. So this policy changes metric basically, kind of shows the track history of the policies which were applied or deleted or updated across the cluster. So let's say as a cluster admin, I want to see that, okay, is my cluster going berserk? Is it creating a lot of policies recently, or is it deleting a lot of policies recently? So you can kind of track that here with this metric. So it's kind of like a transaction log of the policies. And this metric currently operates at the level of policies, not at the rules, because I mean, if you think about it, so rules are a part of policy, right? If a policy is created, it's complied that the rules inside it are created. So basically in Kyverno, from the user standpoint, a user creates policies or cluster policies, not rules per se. So that was the motivation behind, just keeping this metric at the level of policies and not going further down the level of rules, because that would generate a lot of unnecessary noise of metrics and storage. So yeah, you can, like, any policy you update, create or delete, it can be tracked here. And that's basically pretty much it. So it, like, this can actually give the end user the capability, the admin the capability to see that, okay, suddenly, let's say in the last 24 hours, 10 policies were created. So a cluster admin would want to know that what's the situation with that. I mean, like, why suddenly there's a spike in the creation of policies across the cluster. Similarly with deletions. So that's a metric. It might not be very useful for the end user per se, like a developer, but for the cluster admin, it might be pretty insightful metric. And moving on, finally, the pretty big metric, Kyverno policy rule results. So it's a very exhaustive metric. So it basically, the purpose of this metric is to showcase the results associated with any resource hitting Kyverno, any incoming resource hitting Kyverno, and the corresponding processing of rules and policies happening. So for example, I have, let's say, 3 policies which I have applied across my cluster. And like, basically 2 of them are kind of matching the pod request. So whenever a pod is created, 2 of those policies are triggered and they evaluate some validation or mutation rules, right? So there are 2 possibilities. Either the pod's incoming request will be passed or failed. So this metric basically evaluates those kind of situations only. That so right now in front of the screen, you are seeing 2 lines of metrics, right? So basically it is showing 2 situations of validations. So if I actually, it's better if I showcase this metric in a kind of like a practical manner. So right now, currently, the policies which I have applied across my cluster right now is 1 cluster policy and 1 namespace policy. So both of them are same, just like both of them just expect the incoming deployment object to possess the label purpose production. Both of them are the same. The only difference is that one of them is cluster policy and one of them is a normal policy applied on a default namespace. So let me just try to apply a deployment without the purpose production label. So this should violate both of these rules, actually, policies, sorry. And let's just see. Yeah, so it violated this. And if I execute, if I just check on Prometheus, you see new entries were created. And what are these 2 new entries? Basically, this incoming request ended up violating 2 rules. One rule was present inside the cluster policy, this one, the required depth purpose label rule, and the other one was present inside the normal namespace policy. So the good part about this metric is that, first of all, it gives you a fantastic kind of granularity, like all the way from the level of the admission request itself to the policy and finally to the rule name and even the resource. So if, let's say, you want to see that across your cluster, how many violations happened in the past 24 hours for the resource kind deployment. You can just filter on the basis of this resource kind. Simple as that. Similarly, on the basis of resource namespace, and resource request operation. So was the resource trying to get created or updated or deleted? That's tracked here. Secondly, there's a thing called rule execution calls, which simply shows that, okay, like was this incoming request violated or rather mutated or whatever. So not mutated, but yeah, validated due to an admission request or a background scan. Because in Kyverno, processing happens due to two triggers, either admission request or background scans. And we have three kinds of timestamps here. Rule execution timestamp. This one rule execution timestamps, which corresponds to either the admission request timestamp or the background scan timestamp, like the instant admission request or background scan were triggered. And there are other two timestamps. There's one policy execution timestamp. So your policy basically consists, like, it's your policy executing, right? The instant a policy starts getting executed, this is the timestamp which it will do. And finally, there's the rule timestamp. If I'm not sorry, rule execution was this one. Rule execution was this timestamp. So yeah, the rule execution timestamp depicts the exact timestamp of each rule which executed. So let's say a policy has three rules, for example, right? So rule A, rule B, rule C. So this timestamp will differentiate between those individual rules. And I did a slight mistake in the beginning. I actually told that the rule execution timestamp will show the timestamp of the admission request. That was wrong. Actually, it was the main request trigger timestamp. So this is a timestamp which shows that this was the instant in which the admission request was triggered in the first place. So that's the whole idea. And yeah, it also, the metrics also possess rule response, like the exact reason behind why this metric was to crash. So the idea of this is that you can actually perform a fuzzy searching over Prometheus around, let's say, validation error. So you want to see actually that how many validation errors, how many incoming requests ended up causing or triggering a validation error across Kyverno. That's one thing. And yeah, here, like, apart from that, you have generic labels like rule result. It was a failed request. Rule type, it was a validated rule. Similarly, a mutation request could have failed due to any reason. Something would have happened, but if not, then rule result would have been passed. So, for example, I can simply filter right now on the basis of rule result. That, let's say I want to see all my failed requests. So right now there is no change because in this example all of the requests were failed. But actually, let me show you a successful example super quickly. So if I edit my deployment and make sure that it ends up passing the Kyverno sets. Yeah, I have just commented. I just uncomment this label. So right now this was the restriction, right? I have added the label purpose production. If I now apply this, so yeah, the deployment was created successfully. And let me just okay, Prometheus. Oh, my bad. I was actually evaluating the failed result. So yeah, if I enter, two new entries are added, and let me just see the entries which show the successful rule execution. So yeah, you can see that there are two kind of rules which were triggered by the incoming deployments creation, and they ended up reporting the status pass. So the cluster policy one reported the status pass, and the namespace policy one reported with the status pass. So now you can do whatever you want with that. You can even granularize this metric on the basis of policies. Like, for example, if I just want to see that, okay, totally how many, basically I want to granularize on the level of the policy kind, right? Cluster namespace policy. So I can just do policy type, and okay, but there is no policy type here. Sorry, policy, yeah, policy. Oh my God, I haven't applied any function as such. My bad. But now this, for example, this query can actually show the count of the successful rule executions at the level of policy types itself. Like, for example, across my cluster policies, 50 rules have been succeeded till now. Or across namespace policies, there have been 20 succeeded till now. So I can plot them, right? And if I just want to showcase the fails one, you can see that, yeah, I mean, like, there are countless examples. So that's the situation. And the good part, and from the programmatic standpoint, this whole exposure of metrics is not going to that much cause or increase in latency to Kyverno itself, because all of this metric generation is happening in a separate Go routine. So even if, like, due to some edge case scenario something messes up, the already ongoing execution of Kyverno would not be halted. So Yep, that's pretty much the updates. Any questions, anyone? Any suggestions? Any doubts?
A lot of good work. Thank you.
Thanks.
Yeah, it looks awesome.
Yeah.
All right, just a quick time check. We only have 4 minutes left of the hour, so not sure what else we can cover on the agenda, or if you want to, see if there's any other open issues or comments.
Okay, I think we have another like working project, which is integrate litmus chaos testing with Kyverno. Asal Mafuza, you're online. Do you want to quickly introduce yourself and give us like some of the ideas about this project?
Hello, I'm Mafuza Humaira. So I'm working on integration of litmus, integration of chaos, integration of Kyverno with litmus for chaos testing project. So I am okay. Here is the design doc. Shooting is sharing right now. So shall I share my screen?
Okay. I'll stop share.
So you can see I have multiple experiments which all of them will check the Kyverno pod's health in multiple ways. So if I go to the first experiment, here the goal is to verify the stability of Kyverno with a flow of admission request. And here the proposed test will be sending 50 plus admission requests at a time with different types of policies deployed. And the expected result will be Kyverno pod is running all the time. So like this, I have around 14 experiments, and all of them will be helped to ensure the health of Kyverno policies, and it will improve the success and failure test scenarios for policies and testing if policy is behaving as expected or not. Also, I shared the doc in Slack. If you want, you can check that.
Okay, well, this is good. So the idea will be we will use this for running specific tests on different sizes of clusters to see how Kyverno behaves.
Yeah.
Yeah, I was thinking we can spin up a cron job and GitHub Actions, and then this kind of chaos test will be scheduled every like configured interval. We can have it run every day or every 12 hours, etc.
Sounds good. Yeah, this will be pretty interesting to see what the behavior is with some of these load conditions.
Yep. Okay, thank you, Mafuza. Yeah, we only have 1 minute left. We don't have time to cover the rest topics, but I just want to mention that we have an issue with the variable substitution, and we want to change its behavior. There are multiple use cases. Maybe we can discuss this in like tomorrow's contributors meeting. And then there are a few changes in 136. I also attached the issue link there. If you're interested, you can check it out. All right, anything else left for this meeting? Okay, if no, thanks everybody for joining. I'll see you in the next community meeting.
All right, thanks, bye-bye.
Bye.
Bye.